Hello YouTubers and fellow hams. Well, the final video on the little amplifier, we're going to do a modification to fix a deficiency in its keying design. We'll talk about that in a minute. And I'm going to show you how I integrated it into my desk. But first, several people commented on the last video where I was looking at its linearity, asking about its spectral purity and wanting me to do some tests where we look at the second and third order harmonics and how far down they are and how pure the amp's output is. Well, that's already been done. I ran across a blog post, was actually commented over on I think Facebook, and the blog post is by GM4SLV, and he did some quite extensive testing on the amplifier and its filtering and its output purity. He also looked at two-tone distortion. So I will put a link to that blog post in the video description down below if you want to go and read about it yourself. It's pretty well done, and it looks like the amp is clean. Its harmonic filtering was greater than 50 dB down, and its two-tone distortion again was better than what's required. So it looks like the amp is clean. Alright, so a couple of things. I wanted to integrate this amplifier into my desk, and I had to come up with a way of doing that. And this is a plan that I came up with, where I'd make a little shelf for it and 3D print some custom brackets and mount it up under the wooden shelf. So I went ahead and did that. I hopped into Onshape and I designed up the the right angle brackets that I was going to use, and then I ran those off on my 3D printer. And for the shelf itself, I used some plastic that I get from these 88-cent cutting boards that you can pick up at Walmart. A great source of stock material for making things like this. And I made a little shelf for it, and then I took my 3D printed brackets and I mounted it all up. Now, connecting it to my radios. I mentioned in the past video that I was going to do a little trick with diodes and have both radios connected to it at the same time. Thinking about it, I realized there might be a situation where I use both radios at the same time. Perhaps I'll have the FT817 on 2 meters and the RS918 on HF, and I could be keying the amp when I don't want to. So I abandoned that idea and decided to just use a simple switch. Make up 2 different cables, hook up both radios through a switch, and then flip the switch to select one or the other so I don't have to plug and unplug cables. And I went that route. So after I got the brackets printed and assembled everything, I went ahead and made up the cables and wired up my switch, making it as neat as I could make it. And it looked pretty good having the switch right there on the front bracket. Now, wiring up the radios. The FT817 is pretty straightforward, and we'll talk about that in a moment. The RS918, again, pretty straightforward. It has an accessory jack there, and I'll show you that here in a moment. But once I had the radios all wired up, I went to test the amplifier, and I ran into a problem. Okay, it's in. Looks really nice, mounted up under here. It's not going anywhere. Got it all wired into both the RS918 and the Yaesu. And I ran into an issue with that piece of junk. Okay, the RS918 is a cute little radio, for what it is, a Chinese knockoff of the MCHF. Never been a big fan of those kinds of things, but hey, it was given to me for a review. I took a look at it, and I actually honestly still do use it, mostly for shortwave listening. But anyhow, let's see here. I've got the Yaesu hooked up. The antenna switch up there is on the dummy load. So single sideband mode, I key down, I can get power out of it when I talk. I can turn the amp on, and this switch is switched down, which is for this radio, and I don't know if you can see that. Let me shade the light. There, see the light lighting up? The Yaesu keys it just fine. And I'm running 1 watt of drive on the Yaesu. KB9RLW test. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Yeah, okay, I'm peaking about 12 watts. 12 to 15 watts out, which is about what I want to do. Is most of the time I'll be running it like this. I only need about 12, 15 watts, maybe 25. On occasion I'll put this up to, it's 2.5 watts out. 1, 2, 3. 1, 2, 3. Yeah, there I'm peaking about 30. So it's working fine there. Let's turn the Yaesu off. The only thing that I have to do is, this is the input to the amp, is this coax, but I just do this and just hook it up. I could run that. I could put another antenna switch in. I could run that back through there. I got holes in the back for that, but I'll just leave this coax like it is, because then I can also hook this up to the AirSpy SDR if I want to use that, so it's kind of a flexible input. But anyway, power this guy up, and I'll flip the switch to this radio's input, which is hooked up. Grab its microphone, and I'm going to shield the light again, so watch right here for this little red light. I don't know if you can see that. It comes on briefly and then goes dim. So yeah, the RS918 would not key the transmitter. That transmit light on the front came on kind of dim, and I had a pretty good idea as to what was going on. So I took a closer look at the schematic for the amplifier and confirmed my suspicions. Okay, this is the schematic for the amp, but first let's talk about the wiring to the radios. This is the accessory connector on the back of the Yaesu FT817, and the pin that we're interested in is this one here, transmit ground, and that is where the red wire from the keying line on the amp would go. The black wire would then just go to ground or the shield. Either would work, and that's how you'd wire it up for the FT817. Now, I had a viewer ask me about the RS918 to clarify the wiring for that. The accessory jack on that radio is a tip ring sleeve TRS jack, the same size as you'd see on a little, like a set of headphones for a Walkman or something, the smaller size. And on that jack, the push to talk out is on the ring. So you'd hook the red wire to the ring, and you'd hook the ground or the black wire to the sleeve. So that's how you'd wire it up for the RS918. However, as you saw, I couldn't get the amp to key from the RS918. So let's take a look at the schematic. This is the schematic for the amplifier. The only thing he didn't put in here was the low-pass filters, which would be there, but they're present. What we're interested in, though, is the keying, and these two relays here and here are what do the keying. Now, one thing that annoys me about this amplifier design, first off, is the power switch. This is the power switch on the front of the amp over here. But if we look at what that's doing, that's only affecting this rail, which goes to the relays over here. The actual incoming power up here goes right down into the amplifier. So as long as you have that amplifier hooked up to power, the amplifier circuitry itself is live. It's powered up. It's not doing anything because it doesn't have any RF coming in, but it is live. So be aware of that. This power switch on the front does not switch power to the actual amplifier circuitry. As long as you're hooked up, it's live. Well, what are you going to do? I have my power to it on a automobile type accessory plug, the old cigarette lighter plug. So I'll just back that out of the shell when I'm not using the amplifier to cut power to it. But anyway, keying. Okay, keying. These relays are fed power from the 12-volt rail here to their high side. Their low side goes directly out the keying line. So your radio sitting out here has to sync the full current of the relays when it switches that that transmit line. I don't like that. I don't like that for a couple of reasons. One is that the current from the relays has to be completely handled by your radio. Now, most radios are going to have fairly robust switching circuitry on that line, maybe a transistor acting as a switch or a relay themselves. But still, that's a relatively high amount of current for what's essentially a signaling line. In my mind, anything that's a signal line that controls a function in a piece of equipment should not carry very much current. The other problem with this, and it's a bigger problem in my head, is the spike that can be generated by a relay when you disengage it. Okay, so let's just real quick look at what a relay is. Okay, a relay is an electromagnetic coil, and when you apply power to this coil, a magnetic field grows around it, pulling the paddle down and changing the relay contacts. When you disengage power from that relay, that magnetic field is going to collapse, and when it does, it's going to induce a real short spike, a voltage spike in reverse polarity to the way that you engage the power to it. Most of the time in circuitry, you'll see a reverse bias diode added to the relay. And what that does is when you apply power, say positive up here and negative down here, that diode is reverse biased so it doesn't do anything, and the relay energizes and does its job. And then when you disengage power and that magnetic field collapses, that reverse transient spike has a path to discharge through the diode, and that protects whatever circuitry is driving the relay from that spike. So we go back here to the schematic, and there are no diodes indicated on the schematic. In the amplifier, I did not take the board out to look underneath it to see if they were present or not, because that would involve disassembly of the amp. I didn't want to mess with that. But let's just err on the side of caution and assume the diodes are not there. And if they're not there, when your radio out here disengages or ungrounds that keying line, any spike that's generated by those relays, well, guess where that goes? Right on out into your radio. I don't like that at all. So at the very least, you would probably want to add a diode, a reverse bias diode here across these lines to, and it would be, let's see, it would be in this direction, like so. So that when, is that right? Let me see, ground side. No, that's backwards. It would be in this direction. That's important. This is the positive rail here, right? So you'd want to add at least a diode here to absorb that spike from the relays and protect your radio. But my problem is that the full current of the relays has to be synced by the radio, and I'm going to fix that. I did check the resistance of these relays. I found the data sheet on them, and it was 720 ohms, and they're in parallel, so that means 360 ohms, which means at, say, 13 volts, that's almost 40 milliamps of current that the radio has to switch to turn those relays on. Yeah, that's not a lot, but in the case of the RS-918, apparently it can't handle that much current, so it's not keying the amp. So, what am I going to do? Well, I'm going to do this. I'm going to make a single transistor driver for the relays, and I'm going to tuck that inside the amplifier. So what this will do is we'll put this in line with the keying. So this side up here, the emitter on the transistor, and I'm using a PNP transistor, not an NPN, and I'll tell you why in a moment. But this side, the emitter of the transistor, would go to the red wire on the PC board side of the amp, and the collector of the transistor would go to ground, or the black wire on the keying line. This is a PNP transistor, which means when the base is low, the transistor is on. So if the base is below 0.6 of a volt, current can flow through the transistor and the relays would energize. Well, the keying line out to the radio gets grounded when the radio wants to key the amplifier. So what we have here is a 10K resistor going to the 12 volt power in the amp. So when you turn on the amplifier or apply power, that brings the base high, which shuts off the transistor and current cannot flow through it. And then when your radio grounds this side of the wire, the only current the radio is going to see is the current that comes through this resistor. And that's only going to be about 1 milliamp with a 10K resistor. So the radio keys the amp by grounding this line, which takes the base voltage down to 0, and then current can flow through the transistor and the relays engage. I'm using a 2N3906, which is just a general purpose switching transistor. It's capable of handling 200 milliamps of current, so it's going to be fine with the 40 milliamps from the relays. You can probably use just about any general purpose PNP switching transistor. And of course, I've also added a reverse bias diode here, so that if or when the relays disengage and they induce that short little reverse polarity spike, that current will have a direction to go through the diode, bypassing the junction of the transistor and protecting the transistor from that spike. And then the transistor also acts like a buffer, which protects your radio out here from that spike. So we're going to kill two birds with one stone with this very simple little addition to the amplifier. Now, I'll pause the video here and take a screenshot if you want to get this schematic. But as you can see, it's a very, very simple circuit. And we'll add it into the amplifier here where the wires go out to the radio. So let me show you that. This is the little modification. I cut out a small piece of proto board and mounted all the components on it as tightly as I could get them. And I have coming out of the left side there the resistor with the wire that's going to go to the 12 volts and the emitter of the transistor, which is going to tap the red wire on the PC board side in the amplifier. On the right, that black wire is ground. That will tap into the black wire on the keying line, where I just shave a little insulation off of the wire and tap to it. And then the white wire is coming from the base, and that will go to the signaling line where it goes out of the case of the amp into your radio. Here in the back corner of the amplifier, we have these are the wires coming in from the keying line. So this red wire, where it goes into the board, goes to the coils of these relays, which are in parallel. And the other side of those coils is hooked to the power rail, the 12 volts coming in. And the black wire is ground. Now the power wire coming in is right here, but there's enough room in here that my little mod circuit should just tuck right in there like so. And just fit right in that little space. I just need to wire it in. So I've got it heat shrinked and sealed up here, so it won't short to anything. This wire is going to follow the main line up, and I'm just going to tap power right there. I'm just going to follow it along because that's convenient. It's right there. It's easy. The ground wire here, I'm going to just shave so I can tap it and then seal it. And I'll bring, this is the ground wire coming out of my circuit, so I'll bring that around and make its connection. This is the signaling line, which is, I'm going to cut the existing signaling line right about there. And this side coming from the radio will connect to that. And then over here, probably can just barely see the wire sticking out from the emitter of the transistor. Remember, this is a PNP transistor, so it's backwards from what you're used to on an NPN. So that's the emitter. That needs to go to the relay side, so that'll go to the other side of this wire. So then I should be able to connect everything up and just put this right down in there nice and snug, and should be a nice clean mod, and hopefully that'll allow us to switch the amplifier with a grounding signal but no current on the outside. So any radio should be able to switch it. Well, there it is. It fits right in that little spot just fine. All snug as a bug in a rug, as my grandmother used to say. Alright guys, here we go. I've got got everything into the dummy load. Good, no transmit, that's good. That means I wired everything right. We're not locking it in transmit mode. Okay, down would be the 817. Up is the RS918, which did not work before. I've got it turned on. Let's take its microphone and... oh yeah! Can you see that? Oh, you probably can't see that from your angle. How about that? It works! Ha ha ha! Okay, power, dummy load. KB9 RLW test. Oh yeah, it's amplifying. KB9 RLW test. 1, 2, 3. 1, 2, 3. 1, 2. Yeah, good. 30 watts. I've got the RS918 set to 5 watts. It's actually driving about 2. And I was getting about 30 out. So, it works! Haha! Little transistor keying circuit fixed it. Yay! And it's an improvement, I think. So, the modification, it worked. The amplifier now keys properly for both radios and seems to work pretty well. Now, from the previous video, we saw how it has some compression when you drive it with 5 watts in, and gets a little bit of splatter. I'm not going to be using it like that. I'm probably not going to drive it with more than 2.5 watts at the top end, giving me about 30 to 35 watts out. So yeah, that's the way I'm going to use the amp. I'm going to avoid the compression at the high end and splatter, and just not drive it with 5 watts. You know, that's the way I'm going to use it, and it works great. I've used it to check into a couple of nets. Where I'm parked here presently in Vernonia, Oregon, I'm in a friend's driveway right next to some power lines, so I have my shortest antenna up on the back of the RV, so I'm not near the power lines, and it doesn't get out well. So I really don't have good HF where I'm at right now anyway. But that's okay. I've only got about another week, and then I go to my permanent summer spot at the community out in the woods. And I'll definitely have room there to put my real antennas back up and get back on HF. So you'll see this amplifier again probably in a future operational video as we play radio out there in the woods. So I hope you found that useful and interesting, and the little mod, simple enough to do, corrects the keying issue, protects your radio against spikes from the relay coils. I think it's a worthwhile mod to do, very easy to put together. So I hope you found that useful, informative, and we'll see you in the next video. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.